Okay, let's dive into this. Welcome back, focused learners, to today's explainer. Now today, we're taking on a really fun challenge that perfectly mashes up culinary arts with, honestly, precise material engineering. Our mission? We are going to engineer a perfectly structurally sound, savory quick bread batter. You see, we aren't just baking today, we're literally synthesizing a complex matrix right from the ground up.
To make sure we pull this off flawlessly, here's our flight plan for today. First, we'll tackle the pizza muffin challenge. Next, we build out our dry carbohydrate architecture, followed by the lipids and wet emulsion. Then we execute the thermal application. And finally, we'll wrap things up by reviewing the red team's counteranalysis, which is the infamous canned biscuit shortcut.
All right, kicking things off with Section 1, the Pizza Muffin Challenge, and specifically, how we prevent that dreaded doughy core. To really wrap our heads around this challenge, we first need to define what it is we're actually building here. A true pizza muffin is not just some casual snack. It is a synthesized, hyper-portable carbohydrate and protein matrix. I mean, the stakes here are incredibly high from an engineering standpoint. We have to successfully suspend all these dense ingredients. We're talking heavy lipids and proteins like pepperoni and mozzarella directly in the batter. The real trick is making sure these heavy inclusions don't just sink straight to the bottom while baking, which would leave us with a structurally compromised, super doughy core.
Which brings us to a massive structural threat when it comes to proper crumb formation. If we're packing this matrix full of heavy pepperoni and cheese, you kind of have to ask yourself, where exactly does the wet pizza sauce go?
Well, the answer is emphatic: absolutely never in the batter. Folding wet pizza sauce directly into raw batter is, for sure, the critical failure point in most amateur recipes. Doing that just completely destroys any chance of proper crumb formation. To maintain structural integrity, the sauce must be applied purely as a surface glaze right before baking, or, just serve it completely separately post-bake as an external hydration dip. Bottom line, keep that wet sauce out of the matrix.
With those strict parameters locked in, let's move right along to Section 2 and establish our foundational dry chemistry, starting with Protocol Alpha and Beta.
So, Protocol Alpha is all about the dry carbohydrate architecture. In a large mixing vessel, you're going to need 2 cups of all-purpose flour acting as your primary structural base. To that, throw in 1 tablespoon of baking powder. That's going to give us the mandatory CO2 lift necessary for expansion. We add a teaspoon of kosher salt, plus a tablespoon of granulated sugar, which actually acts as a chemical catalyst to speed up the Maillard browning. Finally, a teaspoon of dried oregano and a half teaspoon of garlic powder for flavor. Now, the absolute strict instruction here is to whisk this aggressively. You've got to ensure that leavening agent is homogeneously distributed throughout the entire starch matrix. It's super important.
Once your dry architecture is mixed up, we tackle Protocol Beta, the lipid and protein inclusions. Remember that sinking problem we talked about earlier? Well, here is exactly how we solve it. Step 1. You chop 1 cup of pepperoni into really fine quarters. This is critical because it boosts the surface area for lipid rendering. Step 2. Grate 1.5 cups of low-moisture part-skim mozzarella. And Step 3. This is the brilliant engineering fix right here. You actually toss the pepperoni and 1 cup of that cheese directly into your dry flour mixture. Coating these dense inclusions in starch physically puts the brakes on them sinking during the thermal phase.
But wait, before we go any further, please notice the bold warning here. Do not use fresh mozzarella. Seriously, the chemistry here is totally unforgiving. Fresh mozzarella has an incredibly high cellular water content. If you introduce that into the matrix, that water is literally going to boil inside the muffin while it's baking, completely destroying your carefully constructed crumb structure. So definitely stick to the low-moisture part-skim cheese.
Let's see how this all builds into Section 3, lipids and wet emulsion, which we've designated as Protocol Gamma.
Protocol Gamma introduces the wet components that will actually hydrate our matrix, and it requires some seriously strict gluten management. In a separate bowl, you'll whisk together 1 cup of whole milk, 2 large eggs, and 1/3 cup of a neutral lipid, something like canola oil or melted unsalted butter. Now, it's absolutely crucial to recognize the role of the eggs here. They aren't just there to add liquid, they're acting as your crucial protein binders that are going to hold the whole final structure together once heat is applied.
Now, what's really interesting about this slide is that massive number 15 dominating right there. This represents the absolute maximum number of folds. When you pour your wet emulsion into your dry, inclusion-heavy matrix, you must use a silicone spatula and fold those ingredients together exactly 12 to 15 times. That is it, no more.
You literally have to stop folding while the batter is still kind of lumpy and streaks of dry flour are clearly visible. If you overhydrate or overwork the batter, you develop strong gluten networks. Do that, and you'll yield a tough, bread-like hockey puck instead of the tender muffin crumb we're aiming for.
All right, now we proceed to phase 4, the thermal application, or protocol delta. This is where our raw matrix is finally transformed into its structurally complete state.
Protocol delta relies on some very strict environmental controls. You've got to preheat your oven to exactly 375 degrees Fahrenheit, which is 190 degrees Celsius. After coating a standard 12-cup muffin tin with non-stick aerosol spray, just distribute that lumpy batter evenly, filling the cups almost all the way to the top. Now remember our earlier rule about the sauce? Well, here is where it comes into play. Spoon exactly 1/2 teaspoon of concentrated pizza sauce right onto the top center of each raw muffin. Finally, you sprinkle the remaining 1/2 cup of mozzarella over the tops. This forms a sort of protective lipid shield over the sauce and the batter underneath it.
You're going to bake this matrix for about 20 to 22 minutes. So the crucial point is knowing exactly when the structure is actually finished. The matrix achieves structural completion when the internal temperature hits exactly 200 degrees Fahrenheit or 93 degrees Celsius, and you start seeing some localized browning on the surface cheese. Once it's out of the oven, you must enforce a strict 5-minute rest period in the tin before extraction. Honestly, don't skip this. It gives the internal starches the time they need to properly set and stabilize. To ensure a really thorough overview of our source material, we're shifting gears to Section 5, the canned biscuit counter-analysis, which we're calling the Red Team Report. It's super important to impartially examine popular alternative methods out there in the culinary space. And this brilliantly illustrates the contrasting approaches. The Red Team Report acts as our devil's advocate here, pointing out that a massive subfaction of home cooks completely rejects the batter synthesis protocol we just went over. Instead, they go for a shortcut, pressing raw, commercially canned biscuit dough straight into muffin tins, and then just filling the center with sauce, cheese, and pepperoni. Now, for a quick bias check, the source material does impartially note that the biscuit dough method is indeed significantly faster and, frankly, easier. However, it yields what is fundamentally just a pizza cup. The batter synthesis method we detailed earlier creates a unified chemically leavened cake matrix where the flavor profile is literally baked directly into the cellular structure of the crumb. The biscuit method, by contrast, merely treats the dough as an external vessel just to hold the ingredients. Which brings us right to our final point, and the ultimate question for you, the focused learner. When you step into your own kitchen, are you going to take the time to engineer and synthesize a unified, true structural matrix, or will you opt for the speed of a biscuit vessel? The chemistry is entirely in your hands now. Thank you so much for joining me on this explainer, and I highly encourage you to go test these structural theories out for yourself. Keep learning, keep experimenting, and I'll catch you next time.